The nation's waste streams are an integral element in sustainable development and the circular economy. This presentation addresses two of those pathways, municipal solid waste and agricultural residues, and their status as feedstocks for renewable energy production in California. Thermal waste conversion technologies represent the next generation of treatment for these waste streams, and they are destined to assist in California's quest for zero waste, reducing dependence on landfills and fulfilling the state's goals for renewable energy. And yet, for more than 2 decades, state policy has ignored, indeed discouraged, their use in the production of biofuels and other products from municipal waste. Where do conversion technologies stand today? For well over 20 years, the state has had a definition of gasification in statute that is universally acknowledged to be scientifically inaccurate and which leaves developers vulnerable to spurious legal challenges and possible shutdown due to lack of compliance. The definition restricts the use of air or oxygen in the gasification process, a factor that would disqualify almost all technologies, and requires the entire manufacturing process, not simply the gasification step, to have zero emissions. This is a physical impossibility and a standard that would shut down every power plant, manufacturing facility, or biorefinery project in the state. In statute, conversion technologies, including low temperature technologies, remain generally equated with incineration. Further, MSW gasification facilities do not receive credit as landfill diversion, as the result of which jurisdictions are reluctant to enter into long-term feedstock contracts with project developers. These provisions have long discouraged, indeed prevented, conversion technology providers from developing their projects in the state. Let's look at what has occurred during the past decade. In 2001, SB 341 established a statewide goal of reducing organic waste disposal 75% by 2020. At the time this legislation was passed, CalRecycle said that based upon an estimate of 80 million tons of solid waste that would be generated in 2020, an amount that was actually achieved, California every year would have to reduce, recycle, or compost an additional 24 million tons of material currently going to landfills to reach the 75% recycling goal. Through recycling methods alone, this obviously proved to be impossible. And in 2016, SB 1383 reduced that goal to 50% by 2020 and 75% by 2025. The 2020 goal was still missed by a mile. Other mandates during the decade included diversion credit no longer being allowed for green waste when used as alternate daily cover in landfills, providing source-separated organics collection services to all residents and businesses by 2022, and 50% of the state's power mandated to be renewable by 2025. For companies active in the production of renewable energy from the waste disposal and recycling process, these mandates have necessitated massive changes in how organic waste is disposed in California. Waste management companies, waste haulers, and public jurisdictions are scrambling to find new sources for disposal. However, CalRecycle has virtually ignored the potential for conversion technologies to assist in meeting this challenge. For more than a decade, it has pursued a policy of solid waste management that is narrowly focused on source reduction, reuse, and traditional recycling, while collaborating with the legislature to pass other legislation that is either adverse to or ignores the benefits of applying conversion technologies to the processing of municipal solid waste. From the more than 45 million tons of post-recycled solid waste that will be placed in landfills in 2020 and in 2021 and again this year, conversion technologies theoretically could produce at least 1.7 billion gallons of LCFS compliant biofuels. Approximately 340 million tons of post-recycled municipal solid waste have been landfilled in California in the past decade, and we haven't even made a start. So, how has the state been doing by relying on the traditional hierarchy of waste reduction, reuse, and recycling alone? During the period from 2014 through 2019, the last year for which CalRecycle reported, the state's annual recycling rate declined from 50% to 37%. This is clear evidence that CalRecycle's policies have not been achieving their legislative mandates. And you can see by this chart, the amount of material being landfilled has been increasing dramatically. None of the legislation passed or any of CalRecycle's planning documents published during the period have mentioned conversion technologies as playing any role in helping to improve the state's recycling rate. Thermal technologies are an essential element in any effort to achieve an improved recycling rate, to interdict and make productive use of solid waste before it is placed in landfills, and to produce fuels, chemicals, and biomethane for renewable power production. California statute defines recycling as the process of collecting, sorting, cleansing, treating, and reconstituting of materials that would otherwise become solid waste and returning them to the economic mainstream in the form of raw material for new, reused, or reconstituted products, which meet the quality standards necessary to be used in the marketplace. CalRecycle has not been meeting that definition because it requires material to be raw material for new products, not simply recycled products. Compare this with the statute in New York. When granting a beneficial use determination, the department shall determine on a case-by-case basis the precise point at which the solid waste under review ceases to be solid waste. Unless otherwise determined for the particular solid waste under review, that point occurs when it is used in a manufacturing process to make a product or used as an effective substitute for a commercial product or used as a fuel for energy recovery. Since its founding in 2004, the Bioenergy Producers Association, which I chair, has sponsored 4 comprehensive legislative packages that would have made it possible to use conversion technologies in the treatment of MSW in California. All 4 were rejected by the legislature, the last in 2010, when we were unable to overcome opposition that represented a convergence of traditional recycling advocates and forces within state government. And that was even though 100 stakeholders supported our legislation, including this letter, which was extremely unusual, from the chairs of all three major California commissions: the California Energy Commission, the Air Resources Board, and the signer of that letter was Mary Nichols, and CalRecycle itself. However, their policies significantly changed after this. This legislation was ready for passage after having passed the Assembly, and it was ready to go to the floor of the Senate when the Senate Environmental Quality Committee called it in, and its staff totally gutted the legislation, rewrote it, and made it so negative in terms of our goals that we had to oppose its passage in its final form. But what about the administration policy other than CalRecycle? As long ago as 2010, the California Air Resources Board stated that its number one solution for meeting the GHG reduction goals of the LCFS was to increase the use of biofuels from waste materials. To meet its goals 11 years ago, the Air Resources Board projected the need for 24 new commercial scale advanced biofuels facilities in California by 2020. No high temperature MSW driven biofuels project has yet to be constructed in the state. Confirming what I just said, here is a slide from the California Air Resources Board presentation that stated the need for 24 new potential commercial scale facilities. What has been going on elsewhere in the United States? To begin, biorefineries capable of producing a total of 1.6 billion gallons of renewable diesel from organic feedstocks are now in development or construction, intending to export this fuel to California to take advantage of our own LCFS. I'd like to give you several examples of what's going on. Fulcrum Bioenergy this past summer completed the construction of its Sierra Biofuels plant located in Nevada, approximately 20 miles east of Reno. Using gasification, it will be processing approximately 175,000 tons of post-recycled MSW per year, creating 11 million gallons of renewable synthetic crude oil that will be upgraded to sustainable aircraft fuel. Fulcrum has constructed and is operating its own MSW recycling facility, which is located adjacent to the Lockwood Regional Landfill, which is one of the largest landfills in the Western United States. The plant's municipal solid waste feedstocks are being supplied by Waste Management and Waste Connections, and Fulcrum has previously said that some of it will be trucked across the border from El Dorado County. If this is correct, the county will obtain credit for landfill diversion in California and increase its recycling rate, whereas if the biorefinery was located in California, it would not. Brightmark is commercializing a plastics renewable facility in Indiana that will divert 100,000 tons of plastic waste from disposal each year, using pyrolysis to convert the material into 18 million gallons of ultra-low sulfur diesel fuel and naphtha blend stocks, and 6 million gallons of wax. It's developing a larger facility in Macon, Georgia that will annually convert 400,000 tons of plastic waste into 64 million gallons of low sulfur diesel fuel. the nation's first fully integrated eco-industrial park dedicated to the complete processing, recycling, and reuse of all of the elements of the municipal solid waste stream will be located in Chesapeake, Virginia. Through the sequence of its technologies, 95% of the incoming MSW will be productively recovered for reuse or reused. Among the technologies planned for this facility, it will begin with a recycling MRF that will handle 2,450 wet tons of MSW per day, 850,000 tons per year that are currently being sent to landfill. Using the TRI gasification technology, the same one as is being used by Fulcrum, the facility will produce 17 million gallons per year of renewable diesel and 10 million gallons of Fischer-Tropsch waxes. The inorganics will be fed to a high-temperature plasma-assisted vitrifier from Plasma Power, which will produce construction aggregate and 15 megawatts of power to assist in operating the facility. The project is permitted by the City of Chesapeake with letters of intent in place for financing. In California, it would be virtually impossible to permit and build this facility, and I doubt that anyone would even attempt it. However, in California, none of the repressive statutory and regulatory provisions that have discouraged the development of MSW waste conversion projects apply to single-stream cellulosic wastes. Thus, technology providers and project developers have selected California's Central Valley and its vast resources of agricultural wastes for their entry to the California market. A current survey indicates that renewable energy projects consuming approximately 1 million tons of agricultural feedstocks are currently announced or in development. As we know, the San Joaquin Valley is home to some of the worst air quality in the country. It has 4 of the nation's most polluted metropolitan areas in terms of dangerous spikes in particulate matter. Its primary emissions come from the oil and gas drilling that's taking place there, from diesel trucks traveling through the region on highways 99 and 5, and the agricultural waste decomposition and open field burning. It has the highest asthma rate for children in the nation. During the past decade, 28 out of the 33 biomass combustion facilities in California ceased operations when their power purchase agreements expired and they could no longer compete with the price of natural gas. This left the agricultural industry with very few alternatives for the disposal of its wastes. In 2014, following more than 10 years of consistent decline in open field burning, the San Joaquin Valley Air Pollution Control District was forced to allow the increased use of open field burning until this last February, the California Air Resources Board mandated the annual reduction and complete cessation of this practice by 2025. And indeed, during the past year, there were approximately 1 million tons of ag waste burned in the open fields. Other factors impacting the agricultural community include the elimination of diversion credit for the landfilling of agricultural residues, burdensome regulations imposed to offset unregulated pollution from heavy-duty trucks and other vehicles traveling through the region, the presence of 125 million dead bark beetle-infested trees in California's forests, which were given preference by the legislature when it passed legislation renewing premium power prices for some of the biomass combustion facilities. The exceptional drought conditions that we experienced in recent years resulted in hundreds of thousands of acres of orchards, vineyards, and other agricultural crops being fallowed or removed. And the problem has further been exacerbated by new mandates of the state under the Sustainable Groundwater Management Act that will likely generate significant additional fallowing of agricultural acreage. So here are several Central Valley projects being developed using agricultural feedstocks, which could be applied to MSW as well, and which will help to mitigate some of the problems being faced by agriculture. Aemetis is using the Inentec gasification technology and other processes to operate Aemetis Carbon Zero plant that will convert waste wood to cellulosic hydrogen, which will be combined with renewable oils and hydroelectric electricity to produce 45 million gallons per year of sustainable aviation fuel and renewable diesel. The plant will be located on a 142-acre former U.S. Army ammunitions plant in Riverbank, California. Commercialization is expected in 2024. To further reduce its carbon intensity, the Aemetis production process will capture and inject 200,000 metric tons per year of CO2 from the plant into a sequestration well at the site. San Joaquin Renewables has closed $165 million in funding from Cresta Fund Management and Silver Peak Energy Partners to develop and construct a biomass gasification to renewable natural gas project near McFarland. The project, which will gasify organic waste from orchards and nutshells and convert the synthesis gas into RNG, will be sold as transportation fuel. The project also will sequester CO2 in an EPA Class 6 sequestration well located on the project site. Yosemite Clean Energy has secured a site in Oroville for its first carbon negative green hydrogen and renewable natural gas production plant. The facility will utilize proven Austrian-based gasification technology to produce commercial scale carbon negative green fuels. This will be its flagship dual bed gasification facility in North America, following over 100,000 hours of commercial runtime in developed plants in Europe, Japan, and South Korea. Chevron Corporation, Schlumberger, New Energy, and Microsoft and Clean Energy Systems plan to develop a bioenergy project with carbon capture and sequestration to produce carbon negative electricity in Mendota on the site of a former biomass combustion plant. It'll annually handle approximately 200,000 tons of agricultural waste. During the height of the biomass combustion facilities, Fresno-based West Coast Waste was one of the state's largest orchard removal and disposal companies. They've handled approximately 5 million tons of material over the past 20 years. When the demise of the biomass combustion facilities became clear in the middle of the past decade, they began a worldwide search for disposal alternatives. They fully permitted an anaerobic digestion project at their headquarters in Fresno 5 years ago, and are now nearing final CEQA approval for a companion agricultural waste gasification to power project to be constructed on the same site at their Fresno headquarters. The site is currently permitted for 1,500 tons of material per day. For the first time anywhere, these two technologies will be combined on the same site. This project will also support the initial commercialization of the Verdi pre-digestion technology, which uses thermophilic bacteria to pre-treat incoming feedstocks for anaerobic digestion. The Verde process, which makes possible the efficient use of green waste for biomethane production, represents a game-changing breakthrough for anaerobic digestion. It will enable these facilities to use lignocellulosic biomass that previously has broken down poorly, if at all, in traditional AD technologies, and turn this biomass into a precursor for highly efficient biomethane production. The breakdown of green waste, dairy manure, and food waste will become much more efficient and thorough, allowing up to 80% volatile solids conversion into methane gas, where in the past it has been below 40% for this type of feedstock. With assistance under a $3 million grant from the California Energy Commission, West Coast Waste has been successfully demonstrating the Verde pretreatment process. The demonstration scale program has confirmed that Verde pretreatment is capable of increasing biomethane production from the AD process by as much as 36%. Under the CEC's 2021 grant competition, the company, in competition with 17 other applicants, won a second grant in the amount of $3 million to assist in the commercialization of this technology. To be constructed at the company's headquarters, which has been operating as a recycling facility since 2001, as I mentioned, the site is currently permitted for 1,500 tons of material per day. For the first time anywhere, it will combine these two technologies on the same site. Together, they will annually consume 140,000 tons of organic waste, primarily green waste from the city of Fresno and orchard removals from the surrounding region. This material is already being received at the site. Gasification to power project is unique in that the gasifier will purify the ambient air that it takes into the system by thermally destroying contaminants as the air passes through the gasifier's heating process. As a result, it will emit cleaner air than it takes in. The pollutants in Fresno's ambient air will be reduced by approximately 20,000 tons per year by the introduction of this technology. The project will produce 5 megawatts of renewable electric power using a carbon negative process that will consume more than 200 tons of agricultural and forest biomass per day, and will gasify approximately 98% of these feedstocks. The gasification technology will also annually consume dry digestate from the AD plant and approximately 40,000 tons of agricultural waste, making possible the productive use of material for which no meaningful market exists. The gasifier will purify ambient air by thermally destroying the contaminants, as mentioned. The anaerobic digestion process will annually produce 1,350,000 diesel equivalent gallons of renewable natural gas for pipeline injection, while processing 91,000 tons per year of green, dairy, and food wastes. Annually, it will produce also 7 million gallons of clean water from green waste moisture reduction. The West Coast waste process will offer owners an alternative to open field burning and providing a productive outlet for the disposal of their vines and orchard removals. In closing, I would like to say that the EPA has begun a rulemaking process for the construction and operation of gasification and pyrolysis facilities, which may motivate the state of California to do the same, as they are now and will always be an essential element in the quest to productively reuse organic wastes. Thank you.